Hello. I want to show you how I do calculations with inter-onset durations that I set. So there was a separate video that I made on how to set inter-onset durations in Sonic Visualiser. And now I want to explain how I use the data or export the data and do the calculations in Excel and visualizations. So that means I make graphs. So this is a file of a piece of music, Bach, a prelude in C major. Yeah, I can play it a little bit, and I have the onsets already. Anyway, so I now want to make sure of two things. I save the session. So let's say Schiff is the pianist, and this is my, let's say, my third try of this, and I find the right folder. If I find it, methods of music analysis, let's say. And so what this does is that if I find errors in the onsets just by looking at the Excel file, or for example, if I don't have enough or too many onsets, then I can go back to this Sonic Visualiser file and edit it instead of having to start over. So it's really important to save the session, and then I export the annotation layer. And so I will do this into the same folder. By the way, your session file should actually be in the same folder where the sound recording is. Because if you open it later in Sonic Visualiser, it will look for the sound recording in the same folder. Anyways, here I have options to either save it in seconds or in audio sample frames. Either one is perfectly fine. You just need to know which one it is so you know what to do with the numbers. The audio sample rate is usually 44,100, so you have to divide the numbers through. You have to divide the numbers by 44,100 by the sampling rate in order to get the seconds. So you can do both. I already will actually save it in seconds, so I don't have to convert it. All right, so now I will find the file. So this is the exported CSV file, which I now open in Excel. There in column B here, there may be some numbers that has something to do because I used a VAMP plugin to set the original onsets, but if I make manual corrections, it puts something here in column B once I export that annotation layer. So I can just delete that. And now I have in column A all the onsets, and those are in seconds, in times. And that's based on the audio file that I used. So here's something very important. You have to look at the score. So in this case, this is Prelude in C major by Bach from Well-Tempered Clavier number 1. And you will have to count how many note onsets you should have. well, you should have done this already while you were setting or manually correcting the onsets. But once you have saved your Excel file, you have to exactly count how many node onsets, or you can multiply here. There are 35 measures with 16 onsets each, plus one measure with one onset. So you can calculate that, and you have to double check in your Excel file that you actually have that many rows in your file. So I actually don't. This is just a demonstration. I would have to clean this up. But once I realize I don't have the exact number of onsets, I would have to go back to my Sonic Visualiser session and maybe listen to it very slowed down and see which onset is there, where there are too many onsets. So because the VAM plugin may have set onsets that don't belong there. And when I was correcting it, I may not have caught all of them. So that's a very important thing. So now I want to calculate the onset times into durations. And so how I do this, let me actually make this a little bit bigger so it's easier to see. So here in column A, we have the onset times. Now I want durations for each inter-onset duration. That means from the onset of this C in the left hand to this E in the right hand, then from this E to this G, from this G to this C. So it's not about durations, notated durations. It's the inter-onset durations from the onset of one node to the onset of the next node, and so on. And I chose this piece specifically because it had 16th node inter-onset duration for almost the entirety. Well, for the entirety of the piece, even for the last one. This last node, I don't have a duration because I don't have an onset afterwards. So back to the Excel file. Here is the function column, and I will just say I calculate A2 minus A1. So what it does is takes this cell and this number, which is the timestamp, and subtracts this, which then creates a duration. So if I hit enter, I mistyped this, minus A1, of course. Okay, now I have this in duration. And you don't have to do that for every single node. I'm making this a little bit bigger. You may see that there's a tiny little square on the bottom right of this field once you're clicked in it. And if you double click on this, it does the same calculation for all the other rows. That means this row was A2 minus A1. This is A3 minus A2. This is A4 minus A3, and so on. So it's all sort of automatically done. Now I have the entire piece of music in durations, and those are durations, and they should be all the same if we had a mechanical performance of this piece, because all inter-onset durations are 16ths. From this C to this E is a notated 16th. It's represented by the 16th rest here, and so on. Of course, no pianist performs it mechanically, and that's why all these durations are different. And that's what we want to get at. We want to investigate the expressive timing in music. So now, later on, I also want to compare this recording, which was by Schiff, to another recording, maybe another recording by Schiff or another recording by another pianist. And because every recording has a different tempo in the how the piece was played, we have to calculate a percentage, which means we need an average duration. So let me take 560 onsets and calculate an average. I'll do that somewhere here in a cell. Average 16th. And in the function box, I say equals average, and I take this function, and I now say B1 through B150, 560. So B1 through, and that's with the colon, B1 through B560, because there are exactly 561 onsets, but 560 durations. So that's a formula, a built-in formula in Excel, average, opening parentheses, B1 colon B560. You don't actually have to, actually what we should do is we may consider that pianists do slow down toward the end. So we may actually not take 560 durations, but subtract, let's say, 3 measures. So why we do this is so that our average does not actually include the slowed down notes toward the end, but the regular tempo, let's say, through this measure or so. So there are 16 16th notes in each of these measures. So 560 minus 16 times 3 measures of those. So let me take just 512. It's still very good statistics in terms of an average. So, and that will be in this G cell. And now if I hit enter, I have this average duration. Now this is based on a formula, but I also want this as a value. Why? Because I want to plug this into a formula later on, and if I plug in a formula into a formula, it may create problems within Excel. So I hit copy. Well, I usually use the shortcuts, but I hit copy, and then I paste this into H1, but I paste special, and I just want the value of this. So now I have the same number here, but this is an actual number, and this is the result of a formula. Okay, so that's the difference. Now I can take this number, I can copy it, and I can make percentages. Now I actually forgot to do something. I should have a header here. Shift. Let me see what recording that was. Shift 2017. The 2017 recording by Shift. I should have used row 1 for a header. Why is that important? Because later on I want to visualize it in some graphs, and I need the header for putting in what it is for each line in my graph. You will see that later on. So now I will use a formula, and the formula really is this. 100 divided by the average. Now, I copied this from somewhere else, so this may not be the exact average we have. Of course, I will use the right average that I just calculated. The average 16th note. So 100 divided by the average 16th duration times whatever cell I want to calculate, so the duration cell, or in other words, 100 divided by the average 16th inter-onset duration multiplied by the duration cell. So I will copy this. Of course, I will have to adjust this. I will paste it into here, but I need to adjust that. I will come back to that. I will grab the average 16th inter-onset duration, but the one as a value, not from a formula. And I will go back here and swap this out. Okay. And then, of course, I want to have this based on B1. So I calculate that by B1. So the formula is equals, opening parentheses, 100 divided by the average inter-onset duration of the 16th, closing parentheses, multiplied by B1, and then I hit enter. And now I have the first inter-onset duration, which in the music is from this C to this E, now calculated in percentage. And as you can see, if it was the exact average, it would be 100% or around 100%. This is 140%. So the first note is already prolonged. And it should be prolonged because it's the first beat, the first note, it's the bass note, where there should be a stress. And stress in music can not only be done by playing something harder or louder, but by adding a little bit duration, by prolonging a note. And now I do the same for all the other ones, and I again just click on this little square, I double click on it. And so in B2 was the first inter-onset duration, and so B1 in percentage. In C3 is now B2, B2 in percentage, and so on. Now, if you would have used in your first cell the average based as a result of a formula, it would not have been able to calculate this correctly, or it would have given you an error message. So now I have all durations in percentages, and they go up and down, but they should theoretically all be around 100%. And a few percentage points up or down doesn't make a big difference. But if we have outliers like this one, 127%, that's a relatively big increase in terms of duration. So if I now want to visualize this, I will make this smaller again. So this column C now contains all of the inter-onset durations of this performance in percentage. And now I want to visualize this. But how I visualize this is I want to overlay it with a score so we can easily look at it. And I actually wanted to check if I already had an Excel file, but I don't. So usually I do this in Excel, but you can do this in Word. The reason I do this usually in Excel because I prepared for a conference presentation, and I can also make a copy of what I have in Excel, or take a screenshot and then put it into a paper if I make this as a paper or a publication. So what I will do is I will take a screenshot of the first system, like this. Okay, there are some fingerings that I kind of cut off, and you can be more careful with exactly how you do this. And then I insert that screenshot into my Excel file. It says saves it at the desktop here. So there's my screenshot, and I can make it however big I want it to be. I usually save some space for the header here. And now below that, I will put a graph, and the graph I produce in Excel. But this is important to know because I need to know exactly how many nodes I need to include in this graph. There are two measures of 4 beats each. Each beat has 4 inter-onset durations, 4, 8, 12, 16, so it's 16 times 2, that's 32 nodes. What we see here is 32 inter-onset durations. Well, the last one obviously is from here until to the node in the next measure. But we want to visualize it this way. So I take the first 32 rows, well, 33 actually, because the first row now is occupied by this header shift. So I go to 33 and I highlight this. I click on the first one, I locate 33, I hold on the shift key, and now it's highlighted. And those are the inter-onset durations and percentages of the first 32 nodes. And now I will insert a graph. I like these line graphs with points, or it's called line with markers in Excel. All right, so here it is, and here you see why I have the header, and that becomes even more important if you have several recordings where you have the header, because each will be represented by a line. Excel will put the lines in different colors. I will demonstrate that too in a minute. And then you see this graph, which is in percentage. Now, you don't have to show all of it. You don't have to show 20 because there's none down there. You don't have to show 40, although later in the piece it may possibly do that. So what you can do is let me see. There's a way to limit that. Actually, I forgot temporarily. I have to try to... There is a way to say you should start at, let's say, 40% or 60% and only go to 160 or so. Here, it is here. How did I get there? it's this option. So I double clicked here, I clicked on this, and now I say the minimum is 40 and the maximum is 160. Now watch what it does to the graph if I click enter. Now the lowest number here is 40 and the highest is 160. But you shouldn't necessarily decide that at the beginning. You can adjust that later on. Why? Because you want to have all your graphs for each line of music. You want to have the graph in the same proportions so that you can compare them. And so you may have to adjust that later, or you should really adjust that later on. But anyways, now you have a graph. You can also increase the font size just for these labels, and maybe not necessarily the numbers here, but I find it good to have these percentages a little bit bigger. So now I click here. Now I take a screenshot, and I have an Apple computer, so it's Command-Shift-4. On the PC it may be different. I don't know what it is. Command-Shift-4, and I take this excerpt. And I don't really want these numbers on it. And the reason is I will actually mark them with lines. I will show you. So I take a screenshot of this. Then I go to my either Word file or in this case PowerPoint file. I insert a picture from file. And now I try to line up good, so I need to raise this a little bit. So if you need space for a header, you need to make this a little bit smaller overall. Now you can insert, or you can draw some lines. No, it's insert shapes, lines, like this. So, and maybe that needs to be moved a little bit. And that can be increased a little bit. So now I take this line, I always copy and paste it, and maybe for each downbeat. So then you can count the little circles, 1, 2, 3, 4. So the fifth one is this node, and so on. So I copy that one. So 1, 2, 3, 4. So it's this one. And you can move them around a little bit and so on. So you can sort of line up which value here belongs to which onset as a duration, of course. And then I also like to insert an arrow and make it really thick, like this one. Because if I show this at a conference as a slide, I want people to look at where the 100% is. So if they would see a horizontal line on 100%, it would mean a machine performed this piece very mechanically, that every duration is exactly the same. But of course, in reality, every duration is not the same. And so how humans perform is the goal of this particular research, right? So back to this file. So let's say we have a second performance, and I think I already had another recording. I only have those 32 notes, and I copy that, and I want to paste it in here, but I don't want to paste it. I don't know if it was based on a formula. I will use the paste special, and I just paste in values. Okay. So those were not the percentages. So that doesn't help me. I will undo this. I will go back here. I had already calculated them in percentages right here. So I will, and I only had done this for the first 32 notes. And I will do paste special, values. So it only pastes the values. It doesn't paste the formulas. So let's say, but let's say I have the entire recording for the entire piece. And you can, every line of music now, you can make a graph and you can compare. And how you would do this, then you would always count how many notes you have in one line of music. Like in this first line, you have 32 notes. And then when you make a graph, you select these two columns. Until line 33, it's because I have a header, so that's exactly 32 notes. And now I create a new graph, insert here, insert line with markers, a line graph with markers. And now you can see it made this legend where it says Shift 2017 is the blue line, Shift 1984 is the orange line, and now you can very beautifully compare it. And then again, you can click on this and you can, let's say, cut it out from 40 to 80. If you want it a little bit more horizontal because it may fit better onto your PowerPoint slide, you can actually draw this a little bit longer. Chart title I don't really need, and I will cut off those numbers on the bottom here. I can move the legend into somewhere here, and then I make a screenshot. So, and I take a screenshot of this, and now I have a more horizontal organization of this graph. So let's say I duplicate this slide, and here I will take this out and insert my new screenshot. And I make it however big I need to. So now I can actually lower this, and I have space for a header. And I can bring the lines to the front. No, or I put bring the picture backwards. It's this picture that I have to bring backwards so that the lines are in front. Okay, so now I can line up my lines with the notes 1, 2, 3, 4. So the fifth one is this one, a little bit tricky sometimes, but if you make this bigger, you can figure this out. So 1, 2, 3, 4. So the fifth one is this one. That lines up quite nicely already. So now I have this graph where we can easily see it's the same pianist who recorded it twice, once in 1984 and once in 2017. That's very well possible that the data is not quite accurate. I would have to double check the data. But you can do that too if you want to do the analysis. I just want to demonstrate what I do with the data, how I calculate, how I make the calculations, and how I visualize. And that's how I do it. But there's one more thing I want to show. I use the standard deviation, which is a statistical measurement, the standard deviation as a measurement of the degree of rubato. So I wrote an article about that, which you can read. But Excel has a built-in formula for the standard deviation. So what you do is you calculate, you highlight what you want to calculate the standard deviation of, let's say, to 520. You will have to think through this, but you highlight which values you use, okay, and then you do it differently. Okay, so let's say standard deviation of Schiff 2017, and I make this column a little bit bigger because it was Schiff 2017. And then this is how you do it. You have to do equal and then standard deviation. It's STDEV of, and this is column C. So, and it starts on C2 colon C, let's say 520. Or something like that, or whichever nodes you want to include. And you may actually go through let's see, plus 32. No, it has 35 measures times 16 nodes, 560. The question is whether you want the ritardando at the end as part of your average rubato. I would not, because that's a separate thing. Yes, it is a slowdown at the end, but there could be a performance that is purposefully very even, very equal, with very little rubato, very little expressive timing, but still has a ritardando at the end. And if you include those last few nodes, then that may skew the result of your average rubato value. So you may exclude that. So you will have to think about this. That's all I'm saying, of how many of those inter-onset durations you include. And that's now in this cell, and if I hit enter, I have a standard deviation that's based on the percentages, on the percentage. So that means that there is it's the average deviation from the mean value, and in this case that's 23%, which is not super high. I've seen much higher. But it's also not super low. So it's kind of in medium kind of degree of rubato. But if you would compare that degree of rubato to a performance that is purposefully very mechanical, like my piano teacher always told me, I have to perform very, very strictly in terms of tempo when I play Bach. then that value is relatively high. Okay, so there you have the degree of Rubato, but it's a standard deviation in percentages. Okay. Anyways, that is my video for today. You can leave comments under the video or send me an email, and I may make some other videos in the future.